Hello folks. Alright, so if you are watching this video, it means you're in the second half of this unit circle unit, and today we're going to talk about using trig to find angle measures. It should be approximately page 11 in your notes packet if we're working in the notes packet. Okay, so our plan today is to essentially work backwards. We're going to start with a trig value, and that's going to give us an angle. You'll see what I mean by that. All right, if that's confusing, don't worry. We're going to sort it out right now. Okay, so suppose you're given an equation like this. Sine of theta equals 1/2. Okay, if you're thinking, I don't know what that means, there are definitely some things when you are given an equation about a trig function, sine, cosine, tangent, that you know. For example, you know that this is the y value that we're talking about, okay? Furthermore, that y value is positive, okay? So you know that if you have a positive y value, there's only a few quadrants that angle could land in. It could land in the first quadrant because everything's positive there, and it could land in the second quadrant because that's where sine's positive. And if the y value is 1/2, then you know what the x value has to be to correspond to that. It would have to be √3/2. So that means we're looking at a reference angle of either 30 degrees or pi/6. Okay, so then those land in the first quadrant, so we could say 30 is 30 degrees or pi/6, depending on what units they ask for. But as I mentioned, the sine is positive in the second quadrant also. So are there any other possible values of theta? Yeah. Whatever the angle is when we land in the second quadrant. And that angle is going to be pi/6 with a reference, so it's 6 pi/6 minus a sixth. So that's going to be 5 pi/6, or if we're working in degrees, 150 degrees. All right, so those two are for sure answers, but something we should note about these two is that there are many coterminal angles. So there are infinite answers. And there's a way to write that pretty shortly or more succinctly. That's probably a better way to say that. And how would we describe that? Well, we're going to use a little bit of math notation here. So we could say that theta is pi/6, and then being coterminal means you're going to add or subtract 2 pi. You could do that a ton of times. So we could have that be times n, where n exists in what's called the integers. Okay, so n exists in the integers. If you've forgotten what the integers are, that's all the whole numbers, positive and negative. Okay, and we could say the same thing for 5 pi/6. We could add or subtract 2 pi n, where n exists in z. We're not going to test you on that notation, at least not in this unit, but I think it's useful for you to know and see that that's how you would say all, as in every single possible value of theta. Okay. I'm going to run through just a couple of examples here, and then you can always check the posted key when you try the rest of the problems. So the first one I'm going to show you is the tangent of theta equals 1. Now, before you jump to a problem like I just did, you should always read the directions, okay? And so these directions say that all of our angles are going to be in radians. And we only want to go around one rotation. Okay, so even though I just mentioned coterminal, we're going to stick to one rotation around the unit circle to answer these questions. So theta exists from 0 to 2 pi. All right, so back to tangent. Whenever you're answering one of these questions, think about two things. What reference angle or reference family are we working with? And two, where could this angle land? Okay. Now, when I look at this, I immediately think of pi/4, because the only way to possibly get 1 for my tangent is to be somewhere at one of the pi over 4s. And then I notice that this one is a positive value, which means, please excuse my text messages coming in there. This means that we're looking at the first quadrant, ST, and the third quadrant, first and the third quadrant, because that's where our tangent is positive. So then I want to answer that theta is pi over 4 and 5 pi over 4. By the way, if you don't have sort of these like reference angle families solidly in your head, let's start building those one at a time. So if I wanted to do the like pi over 4 family, so the 4 angles, the first is 1/4 pi over 4. The second one is 3/4, 5/4, and 7/4. If we haven't noticed that pattern yet, it goes like 1, 3, 5, 7. So all the odd numbers. Okay, we'll keep working on that as we do more problems. And by the way, remember, if at any point in time you get confused, make sure you pause the video and maybe go back or write yourself a note or ask a question, or write yourself a note to ask a question, that sort of a thing. All right, next problem I want to take a look at is problem number 9. And the main reason why I want to look at this one is because it's a reciprocal function. Okay, so the first thing I would do if I was you is I wouldn't deal with the reciprocal. I would flip this guy. So instead of dealing with the secant of theta, I would ask myself, what's the cosine of theta? And then I would take the reciprocal of that number, which is going to be -1/2. And now I can figure out this question. So again, I need to figure out the reference angle. So I'm looking for something that has a x value that's smaller. That's going to be my reference of pi over 3, that family. And then because this cosine is negative, I'm looking at not the first quadrant because everything's positive there, the second and the third quadrants. Okay, that's where x is negative, right? So that means my theta is going to be some pi over 3 related angles, specifically 2 pi over 3 and 4 pi over 3. And again, if you don't have those locked in your head, you don't need to have them locked in right this second. But let's go back and write down the 4 that go with pi over 3. So those kind of come up here. And then they're like closer to the y-axis. Okay, so we've got pi over 3 and 2 pi over 3. Then we skip. So 1, 2, we skip 3 because 3 over 3 is 1. So in this guy's 4 pi over 3. And that's a bad 3. 5 pi over 3. So 1, 2, and then 4, 5 in the bottom half of our 4 quadrants. Okay. At least one more to show you here, folks. Okay, so cotangent. Now, there's a variety of ways you can approach the tangent and the cotangent because they can get a little tricky. My recommendation when you see this number, this rationalized number, is to actually unrationalize. Okay, so rewrite it as -1 over root 3. Because then you can say, okay, this is my x value, and this came from, the numerator came from my x, and the denominator came from my y. And then I can just say, oh, everything's over 2, because everything in that first quadrant, that's like a pi over 6, pi over 4, pi over 3. It's all over 2. Now I know my ordered pair. Oh, wait, that looks familiar. I just used that. That's the reference angle pi over 3. But now I want these angles because it's a negative cotangent, which is negative in the same place as a tangent. I want it to land in the second and the fourth quadrant. So I want the pi over 3 angles that land in the second. I already did that one, 2 pi over 3. And the fourth quadrant is 5 pi over 3. Okay, all right. Let's try and find one more that fits a different family. Oh, we'll do number 4. Okay, so similar situation, okay? One thing I would say here, rewrite that over 1. Now when you go to match your y over your x, you've got a little bit of a frame of reference. Okay, so the x value, again, is 1/2, and the y value is going to be root 3 over 2. Aw, shucks. Same exact reference. So this guy's going to be landing in the first and the third quadrant. So I want pi over 3 and 4 pi over 3. All right. Okay, last but not least, we'll do number 5. So in 5, this guy's pretty straightforward. We've got an x value of negative root 3 over 2. That's going to be a reference angle of pi over 6. And then because it's negative, we're going to land in the second and the third quadrants. So that means I need to erase this line because I totally don't need that. 5 pi over 6 and 7 pi over 6. And then to show you the full set of that family, let's go back here down to the very bottom. Here we go. So my pi over 6s are close to the x-axis. So pi over 6, 5 pi over 6. Over here, it's, I think, pretty straightforward. They're like 1 above and below 6 over 6. And then my least favorite angle, 11 pi. Too many parallel lines to draw, 11 pi over 6. So those are your families to kind of keep track of, okay? So try the rest of those problems. Check the answer key. Let us know if you've got any questions. And thanks for listening. Enjoy the rest of your day. All right? See you back here next time. Bye.